This is section 2.3, linear equations. This is these are the topics we will be covering on this section. What are linear equations in one variable? How can we actually tell if that's what we're dealing with when we look at an equation? Well, first off, when we're talking about one variable, that simply means that when we look across the equation, there's only one letter. In most cases, it's typically an x. To tell if it's linear or not, what we would do is we look at the variables. So we look at all the x's, and the exponents on those x's can only be 1. If I see an x squared, it's not linear. If I see an x cubed, it's not linear. If you see an x to the 1/2 power, it's not linear. It all needs to be x to the first power. However, typically when we have x to the first power, we typically just write x and we don't write the exponent. Most of you already know how to solve linear equations. These are the steps I typically use. Step 1 is I distribute and combine like terms on each side of the equation. Step 2 is I get rid of fractions and decimals by multiplying both sides by the LCD of all the fractions. Step 3 is I move my variable terms to one side, typically the side with the greater coefficient. Step 4 is I move my constant terms to the opposite side. Then I divide both sides by the coefficient of the variable term, and finally we check our work. Now, you do not necessarily have to do all these steps. There's some cases where you may only do 1 or 2 of these steps to solve. But this will solve pretty much all of your linear equations if you follow these steps. Let's look at an example of this. We have 5 times the quantity x minus 8 equals 4x plus 7 times the quantity 3 minus x. Our first step is to distribute and combine like terms. So I'm going to distribute on this side. I get 5x plus 40. Sorry about that. I have a typo. I'm going to change this to plus 8 so it reflects it properly. 5x plus 40. On the right hand side, we're going to distribute the 7. We get 4x plus 21 minus 7x. We still have to combine like terms on the right hand side. This gives us 5x plus 40 equals 4x minus 7x is negative 3x plus 21. Now there's no fractions or decimals to get rid of, so our next step is to move our variable terms to one side. So we have a 5x on the left and negative 3x on the right. Now typically it does not matter which side you move it to. I typically move to the side with the greater coefficient. The reason this helps me is when we deal with linear inequalities. In subsequent lessons, it's going to be easier to do it this way. So we're going to add 3x to both sides. So 5x plus 3x, this gives us 8x plus 40 on the left. The negative 3x plus 3x cancels. I'm left with just 21 on the right. We now have our variables on the left, so it means we want our constants on the right, so we're going to subtract 40 from both sides. We're going to get 8x equals negative 19. So x is negative 19 over 8. And typically we should check to make sure our answer is correct. My suggestion is when you have very simple numbers, plug back in and check. When you have time on your test, plug back in and check. But a lot of times as you get more and more comfortable with these, you'll get more and more comfortable knowing that your answers are correct. Here's another example. X minus 2 over 4 plus 5 equals 1/3. Now I have these wonderful fractions here. I don't like dealing with fractions. Notice I have a denominator 4 and a denominator 3. So my LCD is 12. I'm going to multiply everything, or both sides, by 12. I'm going to distribute here 12 times this x minus 2 over 4. Well, 4 goes in 12 3 times, and you're left with 3 times the numerator of x minus 2. This 12 still has to be multiplied into this term, the 5, so the 12 times 5 is 60. And on the right-hand side, 12 times 1/3, 3 goes into 12 4 times 1 is 4. So notice I went from a very ugly equation up here to an equation with no fractions. I still want to distribute and combine like terms. This gives me 3x minus 6 plus 60 is 4. So I combine like terms still. I get 3x plus 54 equals 4. 3x is negative 50, and x is negative 50 over 3. Now we're going to get deeper into equations. There's actually 3 types of equations we want to look at. There's something called a contradiction, where this is an equation where basically there is no solution. There's something called an identity. This is actually an equation where there's infinitely many solutions. And there's something called a conditional equation. When we're dealing with linear equations, this is simply an equation where there's one solution. We saw examples of that in our previous 2 slides. Here's an example of a contradiction. A lot of times we may not know ahead of time that this is a contradiction, but as we go to solve, we find out. We get 2 times the quantity x plus 5 equals 2x minus 7. If we distribute, we get 2x plus 10 equals 2x minus 7. Our next step is to move your variables terms to one side. So if you subtract 2x from both sides, the 2x on the left cancels, and the 2x on the right cancels. And you're left with 10 is negative 7. This is a false statement. We know that 10 is never equal to negative 7, which tells us this is no solution. In other words, this is a contradiction. We also have what's called an identity. Again, these do not always jump out at us right away, but as we start to work on them, we find out this is what they are. We have 3 times the quantity x plus 5 minus 4 equals 2x plus 11 plus x. If I distribute on the left-hand side, we get 3x plus 15 minus 4. Combine like terms on the right-hand side, we get 3x plus 11. Combine like terms on the left-hand side, we get 3x plus 11 equals 3x plus 11. When we subtract the 3x from both sides, we simply get 11 equals 11. This is a true statement. No matter what value we plug in for x, we're always going to get 11 equals 11. So this is what's called an identity. And our solution here is simply all real numbers. Here's another example of a conditional equation. We have 4 times the quantity x minus 2 minus 4 equals 3x plus 11. Distribute on the left-hand side, we get 4x minus 8 minus 4 equals 3x plus 11. So 4x minus, I need to fix this, minus 12 equals 3x plus 11. Therefore, if we move the variables to one side, we get x on the left-hand side, add 12 to both sides, we get 23. We get x equals 23. This equation is only true when x equals 23, and therefore our solution is a single solution. It is x equals 23. Let's take these equations now and talk about applying problem solving or word problems. These are the general steps we'll follow for all word problems. Number one, we're going to read the problem. Once we read the problem, we need to assign what we're solving. In other words, this is our variable. This is what we're looking for. X equals this. Now, we may have other things defined in terms of x. If we're solving for quarters and we're also given dimes, we may have to let x be quarters and then let something else be dimes. But we need to define it in terms of x because our goal here is not to use multiple variables but to use a single variable. Maybe we want to sketch a sketch a diagram. In the case of mixture problems, which we're doing in this section, a table usually helps. We want to write an equation that relates the quantity described in the problem. Then we want to solve the equation and check your solution. Make sure, number one, you answer the question that's asked. Sometimes we'll be on the right track, but we won't have answered the appropriate question. Number two, does your answer make sense based on what's asked? Here's an example. Johnny has 24 coins in his pocket. They are all quarters and dimes. If he has a total of $4.50, how many of each coin does he have? Well, we're trying to figure out the number of dimes and the number of quarters. So we want to let x be one of them. So I'll let x be the number of quarters. Well, I don't know how many dimes he has, but this is a classic example because a lot of times these problems, we don't know the pieces, but we know the whole. We know there's 24 total coins in his pocket. So if x of them are quarters, that means the rest of them have to be dimes, or 24 minus x. Now this is what's considered a classic mixture problem. I'm mixing two things together and getting a whole. When I see a mixture problem, I typically want to set up a table to help me solve it. When I do my mixture problems, my first two rows are the parts, and the last row is the whole. So my first row is quarters, second row is dimes, third row is my total. Now, typically you have an amount, and then you have a value or a percent, then you have a total value. Let's talk about how we fill these in. The amount is simply the amount of each. So the amount of quarters we define to be x, the amount of dimes defined to be 24 minus x, and the total was 24 coins. The value, well, in this case, a quarter has a specific value. It's worth 25 cents, so 0.25 is its value. A dime's worth 10 cents, so 0.10 is its value. We cannot define a total value for each individual coin because they're a mixture, so we leave this one blank. Now, how do we get this last column, the total value? Well, this is very easy. For our parts, we simply multiply across. I have x quarters worth 0.25 each, so 0.25 times x. I have 24 minus x dimes times 10 cents each, so 0.10 times 24 minus x. Now this part down here we don't multiply for, we're actually given it. We're given a total of $4.50. Now the nice part about these mixture problems, you set your table up correctly, this last column gives you your equation. Your two parts added together give you your whole. So in other words, 0.25x plus 0.10 times 24 minus x equals $4.50. We simply distribute, we get 0.25x plus 2.4 minus 0.10x is 450. Combine like terms, 0.25x minus 0.10 is 0.15x. Bring the 2.4 to the other side, you get 0.15x is $2.10 or 2.10. So x is 14. X represents the number of quarters. I have 14 quarters. 24 minus x represents the number of dimes, so 24 minus 14 is 10. So there are 14 quarters and 10 dimes. And we can quickly do the math and add that together and find out that that should add up to $4.50. Here's an example more along the lines of chemistry. It says pure water is added to a 30% solution of 100 milliliters of hydrochloric acid. How much water should be added to reduce it to a 10% mixture? Now we only want to find one thing, and that's the amount of water to be added. In this case, we already know the amount of the 30% solution. Again, this is a mixture problem. My two parts are on the top, my whole is in the bottom. I'm going to take a 30% solution of hydrochloric acid. I'm going to have 100 milliliters of it. I don't know how much water I'm going to have. I'm going to have x of that. And when I add them together, the mixture is going to be 100 plus x. Now the percent of hydrochloric acid in each, well, I'm told 30% for the 30% HCl. 30%, we don't use percentages in our calculations with mathematics. We use their decimal equivalents. So the decimal equivalent of 30% is 0.30. Water has no HCl in it, so it's simply 0. The 10% has 0.1, so 0.1. And again, this last column we're going to get by multiplying it. So 100 times 0.30 is 30. X times 0 is 0. And 100 plus x times 0.1 is 0.10 times 100 plus x. Again, if we do our tables right, our equation pops right out. The two parts added together equals the whole. So 30 plus 0 is just 30 equals 0.10 times 100 plus x. So 30 equals 10 plus 0.1x. Bring the 10 over, you get 20 is 0.1x. So x is 200. So you have to add 200 milliliters of water to dilute the solution to 10%.